Tone mapping operator plays an essential role in HDR imaging. It aims to compress HDR images into LDR images so that they can be displayed on monitors. However, compressing HDR images while trying to preserve the perceptual content as much as possible is a challenging task. Filtering methods decompose an HDR image into a smooth base image and a detail image by utilizing an edge-preserving filter. The base image is usually compressed to reduce the dynamic range, while the detail image is enhanced so that better visual content is preserved. Nevertheless, due to the large amount of parameters, tuning these filters is usually difficult and time-consuming. DeepTMO is a deep learning-based method that is able to tone map high-resolution images. They use a conditional GAN architecture and apply a multi-scale technique to both of the generator and the discriminator to ease artifacts. But their method lacks the variety of subjective styles because of the one-to-one mapping characteristic. Inspired by the filtering methods, our method is formulated as a bicycle GAN framework. The generator pipeline comprises two sub-networks, an edge-preserving net and a tone-compressing net. The edge-preserving net is a kernel prediction network, which is used to decompose HDR images into base images and detail images. The predicted kernel is normalized to ensure the consistency of image tone. This figure shows that the normalization is critical to the tone mapping performance. The tone compressing net estimates the global tone curve, which is used to compress the base image. Let's get back to the generator pipeline. The compressed base image is obtained by the predicted kernels and the global tone curve. The enhanced detail image is acquired by performing a subtraction and an enhancement operation. We then get the LDR image by adding these two images along with some post-processing and color correction operations. This figure shows an example of learned decomposed images. We collect a dataset from multiple public sources to train our models. We evaluate our method on the whole Fairchild's dataset of the original resolution. This figure shows that our results preserve the detail of input HDR images without halo artifacts or over-enhancement. The color appearance of our results are also visually appealing. This figure shows the linearity of our results with respect to latent codes. This table shows that our method performs competitively against existing tone mapping algorithms. We conduct a user study to further verify the performance of our method. Totally, 40 subjects are involved in this test. The result shows that our method achieves higher probability than the compared methods. Our contributions are summarized as follows. We propose a deep learning-based tone mapping method, which consists of an edge-preserving net and a tone-compressing net. By integrating bicycle GAN architecture, our method is able to generate various tone-mapped results from a single HDR image. By leveraging bilateral filters, our method compresses the most part of dynamic range while preserves the high-frequency information of HDR images. Our method performs favorably against existing methods in terms of both subjective and objective evaluations. Thanks for your attention.